All right, we were talking about section 7.6 today. Let's get started. We're going to solve rational equations, actually, we're not going to do inequalities. We are going to just solve rational equations. So let's start. You notice the first two problems are the same. We're going to solve those in two different ways. You can kind of pick your method for this type of problem. Now, the first way that you can approach solving an equation like this, the goal in all of these is really to get rid of the denominators. And then turn it into either a linear or a quadratic equation, which makes it a little bit so that we can actually solve it. And so one thing that you can do here first is you can think of this as just two fractions and think, all right, well, how would I clear out the fractions in the traditional way? Well, if this was like, x over 7, I would times both sides by 7. It's more complicated than that. It's 2 over x minus 7, but the same principle still holds. So if I times both sides by x minus 7, then this is 1 over 1. On the right, I get 2. On the left, I'll get 3 times x minus 7 on top over 5x. And then I can clear out this fraction, so I can times both sides by 5x. And on the right, I get 10x. On the left, I get 3x minus 7. Sorry, 3 times x minus 7. And then I can distribute the 3, so I get 3x at minus 21 equals 10x. Subtract the 3x over, I get negative 21 equals, let's see, maybe 7x, and then x equals a negative 3 for my answer. So that's one method. Another method, and the method that I'm going to use on the more complicated problems, is what I call clearing out all the fractions at one time. So you try to clear out every fraction in the equation all at once. So that just requires you finding the common denominator between all the fractions. This one is pretty straightforward in the sense that there's only two things to think about. There's x minus 7 and 5x, and because there's no common terms, I'm just going to times both sides by 5x times x minus 7. Okay, so what do I end up with? Well, I end up with 3 times 5x times x minus 7 on the left, just multiplying everything on top here, all over 5x. That's equal to 2 times 5x times x minus 7 on the right, all divided by x minus 7. Check it out. On the right, x minus 7 over x minus 7, that simplifies to 1 over 1. 5x over 5x, that simplifies to 1 over 1. So I get 3 times x minus 7 is equal to 2 times 5 is 10, so 10x. Distribute it through. This is probably going to look familiar. You end up getting x equals negative 3 again. Okay. So on this one, it probably doesn't matter. Pick your favorite method. Neither one is less work necessarily. It's just sort of how you think about the problem. So when we go down to these problems, though, I'm actually going to err on the side of the second method, which is trying to clear out all the fractions at once. And I'll show you why. So I'll give myself plenty of space here. My first goal, if I'm looking for a common denominator, is to factor each denominator. So here, x minus 3, that doesn't break down any further, so I'll just write down 6 times x over x minus 3 equals, and I've got 8x squared, not doing anything with that, but this x squared minus 9, that does factor. It breaks into x minus 3 and x plus 3 minus 4x over x plus 3. All right, so now I look at all my denominators, and I see that there's an x minus 3, an x minus 3, an x plus 3, and an x plus 3. So in other words, my common denominator will just be x minus 3 times x plus 3. That will clear out all of the denominators. You'll see what I mean here in a second. So I'm going to times everything, both sides, by x minus 3 times x plus 3. Again, because that's that's all of the terms or factors that are shared amongst all the fractions. So I'm going to go x minus 3 times x plus 3, x minus 3, x plus 3, x minus 3, x plus 3. Now if I do that, then I can see right away that a bunch of things are going to simplify. And I can do this without rewriting it. Up here I rewrote it, but here I don't even need to. X minus 3 over x minus 3 is 1 over 1. X plus 3 over x plus 3 is 1 over 1. X plus 3 over x plus 3, that's 1 over 1. X minus 3 over x minus 3, that's 1 over 1. So now I can just copy everything down. So I've got 6 times x plus 3. That's equal to 8x squared. Well, there's nothing else there, so just 8x squared. minus 4x times x minus 3. So minus 4x times x minus 3. And now I've got just an equation to solve. So this is going to be, when I distribute the x, I'll get 6x plus 18 equals 8x squared minus 4x times x is 4x squared. So 4x squared minus 12x. 8x squared minus 4x squared, that's going to be 4x squared. I'm going to subtract 6x over to the right. And so that'll be minus 18x equals 18. Sorry, 18x equals 18. Minus 18 over. And so I get 0 equals 4x squared minus 18x minus 18. And then there's a couple ways that you can solve this. Quadratic, probably at this point, since we're just trying to find the solution, the easiest way is going to be just to graph that thing and find the zeros. So we'll open up Desmos here, and we will type in 4x squared minus 18x minus 18, 4x squared minus 18x minus 18. And so this is what you get for the graph. But again, we're just trying to find the zeros to solve it here, so we get that and that for our answers. Negative 0.842 and 5.34. Actually, so these numbers, as I was looking at them, sorry for the weird hiccup here. Anyway, these numbers didn't come out nice, and so I suspected I made a mistake. I did make a mistake. Maybe you guys all saw this, but negative 4x times negative 3 is plus 12x here. So when you subtract the 6x, you will end up with a positive 6x here and not minus 18. So this will be positive 6x and then when you solve this out, you end up with x equals 1.5. I can show you the graph here. So here's your answers. Negative 3 is a solution, but when you plug negative 3 back in, you see that it's an extraneous solution. So it's a solution that shows up algebraically, but isn't actually the solution because it creates a divide by 0 error. So your answer is x equals 1.5. All right, let's go on to the next problem. So again, I want to clear out the fractions. This fraction has a denominator 1, so we don't need to worry about it. But I have a factor of x minus 5 here, a factor of x over here. So I'm going to times those sides by the common denominator, which would be x times x minus 5. And then, I'll use a different color here. So then I'm going to times everything by x times x minus 5. So x minus 5 here, and x minus 5 here. Okay, remember we're multiplying. So all of that times 1 is just x times x minus 5. So I'll write that x times x minus 5. X times x minus 5 times 8, but I have an x minus 5 over an x minus 5 here. So I just have 8x. Here I have x over x, that's 1 over 1, so I have 3 times x minus 5. And then just finish it out. So I've got x squared minus 5x minus 8x equals 3x minus 15. Move everything to the left. Oh, well, actually, sorry, combine the terms. So I have x squared minus 13x equals 3x minus 15. Minus 3x from both sides, I get x squared minus 16x, and then add 15, so I get this, equals 0. This one's not too bad to factor, so I'll just do that real quick. X and x, minus 15 and minus 1. And so my solutions are 15 and 1. I check them back into the original problem. Neither one creates a divide by 0 error, so my answers are 15 and x equals 1. All right. It would be a good idea for you to go ahead and try the next problem, which is number 5. So let's spin this around here. All right, so now let's finish this out. I've got my common denominator is going to be, I'll need a factor of 5, a factor of x, and a factor of 2, and that'll clear everything out. So I'll times every fraction by 5 times 2 times x. this right here would be times 5 times 2 times x. This one here would be 5 times 2 times x. And then I just simplify. So 5 over 5, that's 1 over 1. X over x, that's 1 over 1. So right here, I'll have just 2. I can zoom in here so it's a little bit. You can see it a little bit better. All right, so that'll just be 2 times 2, which is 4. Minus 5 times, so we've got 2x over 2x, that's just going to be 5. Equals 2 over 2, that's just going to be 5x, negative 5x. And then I can just solve the equation. So this is negative 1 equals negative 5x, and x equals positive 1/5. And that's it for that one. You check it real quick. It does not create a divide by 0 error, so that is your one solution. Okay, to answer this word problem, I want to rely on a formula that's going to come up pretty frequently in the rest of Algebra 2. It also shows up in physics quite a bit, and is maybe in some sense sort of common sense, I guess, a little bit. But anyway, let's read the problem first. Every year, the junior and senior classes at Hillcrest High build a house for the community. If it takes the senior class 24 days to complete the house and the junior class 72 days to complete the house, how long will it take them if they work together? Okay, so the way that we're going to look at this is we're going to think of the distance equals rate times time formula. The only thing is distance in this case is not really a distance. It's really just how completing a house. Okay, so if our distance is, completing a house, then one house gets completed for, if we're looking at the juniors here, no, I'm sorry, let's start with the seniors. If we're starting with the seniors, one house gets completed in 24 days. So we'll take, we'll call the senior rate S times 24. Okay, so again, our distance, quote unquote, is one house. That's the amount of house that they're going to build. They can do that in 24 days, and then S is going to be the rate that the seniors complete a house in. So we can solve, well, we'll come back to that in a second. Well, no, we can do it right now. Divide both sides by 24, and I get the rate. S equals 1 over 24. One house per every 24 days, all right? We'll do the same thing for the juniors. So the juniors complete one house every 72 days. We'll call the junior rate J. That should be 72. Okay, so 72. And so J is equal to 1 over 72. What is going on here? 72, all right? So I have the rate for J is 1 over 72. The rate for S is 1 over 24. So if we want to figure out the rate that they complete a house together, it would just be S plus J. In other words, 1 over 24 plus 1 over 72. That would give us the combined rate. Maybe we call that C, okay? And so then the last section here is the rate combined, so they can complete one house at a rate of, well, 1/24 plus 172. So you can either do that the old school way, or you can just go 1 divided by 24 plus 1 divided by 72. Fraction that, it's 1 over 18. So that's 1 over 18, and we want to know the time. We don't know what that is. So to figure out what t is, we just times both sides by 18. And so we get 18 equals t. So the amount of time is 18 days. Okay. We'll do more of those in the assignment and look at them in class just so we can get comfortable with them, because there's a lot of moving parts in those word problems. But I think you can get the hang of it by the time we're done.